Okay, so we've already talked about factoring. We've factored easy quadratics. We've factored hard quadratics. You also factored in Math 1. Now, whether or not you remember it, it was there, it happened. So today, we're going to solve quadratics by factoring. So we're actually going to find what x equals. And remember, when we're talking about solving quadratics, we're finding where the quadratic hits the x-axis. We're finding the x-intercepts. We're finding the roots. We're finding the zeros. Okay? And our learning target is I can solve quadratics by factoring. Okay. So here's the objective. To find quadratic solutions, and remember that these are called roots and zeros, so solutions, also called x-intercepts, that's why it says etc. And we're going to solve them by factoring rather than graphing. So we're going to find the solutions of this equation right here. And these are the steps that we're going to use every time we solve by factoring. So we're going to set the quadratic equal to 0. And if it wasn't equal to 0, if it was equal to another number, we would get everything to one side and make it equal to 0. Alright, so check 1. Step 2, we're going to factor the left side. So if you'll notice, this is actually an easy quadratic. We need to find two numbers that multiply to give us -10, but add to give us 3. It takes some people longer than others, but those two numbers are 5 and -2. So then our two factors are x plus 5 and x minus 2. And remember that we are now solving equations, so it equals 0. So check. Step 3, we're going to set each factor equal to 0 and solve for x. So x plus 5 is a factor. We're going to set it equal to 0. X minus 2 is also a factor. We're going to set it equal to 0. And we're going to solve for x. We're not going to just automatically make it the opposite side, because if you start doing that, when we get to harder problems, you're going to mess up. We're going to solve for x. So the way we get rid of a plus 5 is we subtract 5 from both sides. So x equals -5. And then the last thing we're going to do for x minus 2, we're going to get rid of minus 2 by adding 2. So x equals 2. Okay. So this one says write your answer using curly brackets. So you might see it like this: x equals curly bracket -5, comma 2, curly bracket. I do not care which one you do. So I'm probably going to start doing just this one, but just know that if you see this over here, it means the same thing. Okay, so step 1, we're going to make sure it's equal to 0. It is. Step 2, we're going to factor. So this one is an easy quadratic. We just need to find two numbers that multiply to give us 3, but add to give us 4. Those numbers are 1 and 3. So my factors are going to be x plus 1, x plus 3, and they equal 0. So now I'm going to take both sets and set them equal to 0, and then solve for x. The way I get rid of a plus 1 is subtract, so x equals -1. The way I get rid of plus 3 is subtract, so x equals -3. My two answers are -1 and -3. Okay. This one also is an easy one. So anytime there's a 1 in front of x squared, remember that's our easy problems. So I need two numbers that multiply to give me 24, but they have to add to give me 11. Those two numbers are 8 and 3. So my factors are x plus 8, x plus 3. They both equal 0, so I'm going to set them both equal to 0. And I'm going to solve for x. I'm going to get x by itself. So the way I get rid of plus 8 is subtract. X equals -8. The way I get rid of plus 3 is subtract. X equals -3. There are my two answers. Same thing with this one. Easy problem because there's a 1 in front of x squared. I need to find two numbers that multiply to give me -2. But those two numbers have to add to give me 1. So remember, there's an understood 1 in front of x. Okay, only two numbers that do that are going to be 2 and -1. 2 and -1. So my two answers are x plus 2, x minus 1. They both equal 0. I'm going to set them equal to 0. And now I'm going to solve for x. The way I get rid of a plus 2 is subtract. So x equals negative 2. The way I get rid of a minus 1 is add. So x equals 1. Okay, once again, an easy problem because there's an understood 1 in front of x squared. I need two numbers that multiply to give me negative 27, but they have to add to give me 6. So sometimes it takes people a little longer. These numbers are 9 and negative 3. Alright, so my two factors rather, are x plus 9, x minus 3. They equal 0, so I'm going to set both of these equal to 0. And then I'm going to solve for x. The way I get rid of a plus 9 is subtract. So x equals negative 9. The way I get rid of minus 3 is add. So x equals 3. Okay, so I want you to try these two. So I want you to pause the video in 1, 2, 3. So you're looking for two numbers that multiply to give you 25, add to give you 10. Both those numbers are 5. So now I know my factors are x plus 5 and x plus 5. I'm going to set them equal to 0. And I'm not going to do both of them because they're both going to be the same thing. And now I'm going to solve for x. So x equals negative 5. This one only has one answer, and if you had graphed it, it's only going to hit the x-axis one time. The second one usually throws people off. Those two answers and two numbers are going to be negative 4 and negative 4. So I have negative 4 and negative 4 equals 0. I'm only going to do one of them. And I don't need parentheses. I don't know why I wrote those. I'm going to add 4 to both sides. X equals 4. If you were to graph it, it would only hit the x-axis once, and it would hit it x equals 4. Alright, so now let's factor with some hard ones. Okay, so these are different because you have a 3 in front of x squared. Okay. Remember that you always want to look for a GCF that you could take out. So if you'll notice, 3 is divisible by 3, 9 is divisible by 3, and 12 is divisible by 3. So 3 is the greatest common factor. And then, when I take out a greatest common factor, I'm really dividing. So 3x squared divided by 3 is x squared, 9x divided by 3 is 3x, and negative 12 divided by 3 is negative 4. Okay, and then I'm just going to continue on like I would have. I'm looking for two numbers that multiply to give me negative 4, but add to give me 3. Those two numbers are negative 3. Oh, no, they're not. Embarrassing. Negative 4 and positive 1. Nope, nope. Try again. Sorry. I am brain dead. Okay, try this again. 4 and negative 1. Good job, Miss Slate. There we go. Alright, so here's what I have. I have a 3, I have an x plus 4, an x minus 1, and it equals 0. So technically what you do is you take all of this and set it equal to 0. However, 3 equals 0 makes no sense. So it kind of just goes away. Alright, this one's going to be negative 4. This one's going to be 1. So you only have two answers. You can graph them and check it. Alright. This one's the same thing. We're going to look for a GCF. 5. This one's divisible by 5. This one's divisible by 5. This one's divisible by 5. So 5 is going to be our GCF, and then we're going to take out the GCF, which really means divide. Okay, so now it's actually a simple problem. We need two numbers that multiply to give me negative 12, add to give me negative 4. Let's see if I can do better this time. Yay! Alright, so here I have 5, I have x minus 6, I have x plus 2, and they all equal 0. So when you do 5 equals 0, x minus 6 equals 0, x plus 2 equals 0, one of these makes no sense at all, so just cross it out. So x equals 6, and x equals negative 2. Okay. Alright, so here's where we get really tricky. this one does not have a GCF because 1 is the only number that they're all three divisible by. And this one is not an easy quadratic because you have a 2 in front of x squared. So we're going to have to multiply the a and c term. So we're looking for two numbers that multiply to give us 2 times -5, which is -10. It also has to add to give us the middle number, which is 3. So that's how this one is different than the other ones we've done, because this is a harder factoring problem, so you have to do the a times c terms. So the only two numbers that are going to work are going to be 5 and -2. And I'm going to take these two numbers and I'm going to replace that middle number. So I still have the 2x squared that I originally had. I'll have the -5 at the end. And the only thing I'm going to change is now instead of plus 3x, I'm going to do plus 5x minus 2x. So what I'm trying to do is I'm trying to break apart that middle so that I can start factoring. Okay. And now I'm going to group the first two together, and I'm going to group the last two together. And I'm going to pull out a GCF. So if I look at the first one, the parentheses in green, the only GCF I can take out is x. And when I take out an x, I'm left with 2x plus 5. Alright, and then if I look at the purple set of parentheses, see how the -2x is negative, so my GCF is definitely going to be negative. And the only thing that they're both divisible by is -1. And I'm going to be left with 2x plus 5. Okay, so notice how both of these have the 2x plus 5. So that's going to be my binomial GCF I take out. And then these were the two things that I took out from my GCF, so that's going to be what's left over. Okay, if that doesn't make sense, then go back and watch those factoring videos. So now I'm going to take the factors and I'm going to set them equal to 0. And this is why I said don't just do the opposite, because it doesn't work for that first one. So what I'm really trying to do is get x by itself. So I'm going to get x by itself by subtracting 5. 2x equals -5. And then I'm going to divide both sides by 2. So I have x equals -5/2. For x minus 1 equals 0, I'm going to get rid of the -1 by adding. So x equals 1. There are my two answers. Okay. So not a GCF to take out, but because we have a number other than 1 in front of x squared, I'm going to have to do the a times c terms. So when I do 8 times 5, I get 40. I'm looking for two numbers that multiply to give me 40, but they have to add to give me that middle number of -22. Okay, so those two numbers are going to be -20 and -2. Okay, so remember, I'm taking those two numbers and I'm rewriting that middle. So 8x squared stays, plus 5 at the end stays, and instead of -22x, I'm going to have -20x minus 2x. And now I'm going to start grouping. So I'm going to group the first two together, and I'm going to group the last two together, and then I'm going to pull out a GCF. So if I look at the green parentheses, they have a GCF of 4x, and when I do that, I'm left with 2x minus 5. For the orange, because you have a -2 at the very beginning, because you have a negative, your GCF is going to be negative, and the only GCF I can take out is a -1, and I'm going to be left with 2x minus 5. Okay, so notice they both have a binomial of 2x minus 5, so that's going to be one of our factors. And then they both have well, these were the two GCFs we took out, so they go together in a parentheses. That doesn't make sense. Go back and watch those previous videos. So now I'm going to take these factors, I'm going to set them equal to 0 and solve for x. Alright, I'm going to get rid of a minus 5 by adding. I'm going to get rid of timesing by 2 by dividing. So 5 halves. For the next one, I'm going to get rid of minus 1 by adding. I'm going to get rid of timesing by 4 by dividing. So x equals 5 halves and x equals 1/4. Alright, so this one has a GCF. Sometimes it's kind of hard to notice, but they're all divisible by 2. So that's the first thing I'm going to do. I'm going to take out a 2 and I'm going to write what's left. So x squared plus 5x plus 4. This is an easy quadratic because you have a 1 in front of x squared. I'm looking for two numbers that multiply to give me 4, but they have to add to give me 5. 4 and 1. So here are my factors. And I'm going to take all of these, set them equal to 0. This one doesn't make sense. This one becomes -4. This one becomes a -1. Okay. Alright, so this one, it has a GCF that you can pull out. If you want to try it, you can. You can pause the video. If not, the answer is 4. They're all 3 divisible by 4. So I'm going to take out a 4. I'm left with x squared minus 6x plus 7. This is an easy quadratic. I just need two numbers that multiply to give me 7, but they have to add to give me -6. Okay, so if you're having trouble coming up with the numbers, that's good, because this one is actually not factorable. Sometimes you're just going to have quadratic equations that you can't factor, and that's okay, because we have all these other ways to do it. We've already looked at graphing, and then this week and next week I'm going to show you some other ways that we can solve quadratics. So not every quadratic is going to be able to be factored, and we would just say not factorable. Don't say no solution, because it's not no solution, it's just not able to be solved with factoring. Okay, so I want you to try this one. I want you to pause the video and see if you can do it. So pause the video in 1, 2, 3. Okay, so first you gotta find the two numbers. They're 15 and -2. Then you gotta use them to rewrite the middle. Then you're gonna group the first two and the last two, and you're gonna start pulling out GCFs. So I've taken out my GCF, I've gotten my factors, and now I'm gonna set each factor equal to 0 and solve for x. Okay, so you should get x equals -5 and x equals 2/3. If you got it right, awesome. If you didn't, see if you can figure out your mistake. And I'm gonna give you one more to try. So go ahead and try this one. So your numbers are going to be -3 and -5, and now you're going to rewrite the middle using those numbers. And then you're going to start taking out GCFs. So now I know how it factors, and I'm going to take my factors and set them equal to 0 and solve for x. So my two answers are 3/5 and x equals 1. Alright, so some stuff for you to try on haiku. If you have any trouble, let me know. Alright, bye.